This is something that's important when you have a data-heavy company. You should have a clear data strategy. It should, all of these points, this is just the point that should be in a data strategy, should be there. It's something you have gone through and has a clear understanding and presentation of. So it could be presented to everyone in the company. So it has to go well with the vision of the company, and you have to have a clear data governance. That's so important. You have to understand the architecture, as we talked about, all the different life cycles, both for the models and for the data. That has to be there, and yeah. So these are that's an important part of every modern company or data-driven company now. But we can come back to if it's. So this governance is a part of the data strategy. So data governance is more about how do you handle the companies that are in handle the data that in this company. So before it was used to be structured like the model department or credit department has their own data and they has their own models. So it has a data mart and it has some models they make, and they are all separated from the rest of us. And then markets or the private investment part of the bank, they have the different models, they have different data and so forth. And that's not good enough. So now we have to have something that has a clear responsibility for all the data and can spread it across the company at all the different levels. So that also includes making sure that the data is up to the standard. Everyone knows what kind of data that the company has. Everyone has access. Everyone that needs access has the correct access, but not too much. Regards to GDPR, another California Data Act and so forth, and the quality. So that's an important part of. So data is gotten so much bigger in the last couple of years. You can't just sit down and model it all by yourself. You have to have a whole lot of infrastructure around you. Okay, so let's move on to talk a little bit more about the step down to the actually modeling and data collection. So the data and model pipelines, like you guys are DevOps guys, and you have DevOps had this, and both traditional IT had this own kind of journey from being waterfall and very slow to being more to have a clear best practice way that everyone does it. Like this, you should have continuous integration, you should have this, you should that, and this is how we do it. You should have pipelines to test it and so forth. And ML, machine learning and data has not had that traditionally. This just last maybe 5 years that's starting to have a huge. People start to understand that we need something similar in machine learning, but it's not the same. So people have been adopting the same ways to doing stuff, lean and all the CI/CD kind of stuff, and try to press everything into that kind of framework, like storing your models in Git, storing your data in Git, and so forth. And it doesn't work completely, or not at all. But now we're starting to move on to. But now there are complete specter of complete ecosystem for this MLOps. But you can think about it should work the same way. It should be able to go smoothly from data and testing out to having something in production. It's the same underlying basic idea that things just move smoothly. You should not have to manually copy paste your code into a different system and maybe change some parameters in an interface from the 80s, and then you maybe get something in production and then it's error prone and you misspelled or it's 0.2 instead of 2.0 and all those kind of stuff. It's a huge and interesting area, there's a lot of very interesting applications that come into play here. Yeah, let's move on. Yeah, so so that's what enables us to do large scale or production type of highly updated kind of models where you need to be trained continuously, and the models need to handle a large amount of requests, and so they have to have a good uptime. You can't just have you can't have a chatbot that has downtime. So you have to have the same requirements as you do in traditional IT. So you're starting having to have, when you're doing online credit evaluation, or you're requesting to get a loan at DNB, the models have to be there continuously, so you can see. So you don't have to. Yeah, the customer needs it to have the same trust in that as in traditional or the other web pages. All the rest of the infrastructure for IT. And they have to be scalable in the same way. Like if you suddenly get a spike in in the demand, it should scale out the same way as other IT systems. Like you have it in a container and you just put it on a Kubernetes, and it should automatically be running 10x the servers. And it's very important. Another part that's even more important than in traditional is you have to have insight into the models. You have to see how well they perform. And that's usually been a yearly exercise. Like you have some regulatory requirements for banks when it comes to credit models, that you have to report on how well the model perform, both to external, like financial supervisor, and to internal, like the board and others. But now we have to have more like this should be a daily report, maybe monthly, daily, weekly, whatever. What kind of new data? How well is the model predictions been in regards to actual realizations? And the whole process, I'm just going to say a couple words about that. When you design systems like that, when you design a new model, for example, you have to know, do you need new data? If you need new data, you have to design systems to continuously get that data into your system. So you have to decide on where should I store it, what kind of storage do I need, how fast a lookup, is it acceptable with some delay in the response? Is it non-acceptable? Is it a text search? Is it a column? Do you only use a couple columns? So I maybe use a column database. Do I use a non-structured database, no SQL database, where I can query more like a JSON query, doing on a JSON, other stuff like that. Do I need online? Do I need to analyze it online or offline? And do I have relational data? Is there a best way stored to a relational database? Do I have to create a specific scheme, or can I be more generic? So there's a lot of things that you have to think about. Yeah, so as I talked a little bit about how we've seen the move, that's been a trend the last 10 years, maybe, moving from data warehouses to data lakes. And now we're also moving away, both from data lakes, or not away, but building more on top of it, making lake houses that are more structured and unstructured at the same time. People also moving to more data mesh, that is something like a little bit in the area of data marts. It's more decentralized end user places. There's heaps of regulatory pressure building on the last years. So GDPR, it's so much you have to have control of there. There's also starting to be things like bias. Is your model biased in any way? Does it pick out people with names, foreign names, for example? How do you know that they're not getting less opportunities because of these models have some there are some structures in data that they pick up that show so the end result is that some people get less opportunities. So that's something you have to look into. You also want to have zero ETL. You don't want to wait one day before you can do analysis on the data. So you might want to look at the data directly. So this move towards zero ETL, meaning that you could, whatever query language you're using, or wherever you use it, instead of having to move from one database to from operational database, for example, to analytics database, you can just have a pass-through, meaning that you're able to query directly on the operational or the first entry for the data. There are other also solutions to that, but more and more to having a very small delay in the ETL or no one at all. That's getting important. So your data analyst is not working on last month's data. They're working on real-time data. AI is also moving into AI itself. So AI is starting to build models that can supervise itself. So you're having models that could look into the data quality, models that could see how is the model performing itself. So we're getting this new level of another dream within a dream. There's another model supervising another model. So we're building on. So you're getting a lot more complicated there too. So you can see how is the data you collected? Is the distribution the same as last month, or do you have a lot more outliers? That could be something that the model picks up and warns you about. Is the data not statistically structured the same way? And you can get some kind of warning that this is something you have to look into. This is changing too much.